Next one is working out the median mode and range from a frequency chart or a bar chart. Right. We discussed this before, that a good way to display data is in a bar chart. Remember when they're in separate categories. Now, can you remember whether this was discrete or continuous data? Have a think. And hopefully you come back with discrete data, and it's true. So they'll ask you questions looking at that as, which is the most popular event? Hopefully you'd say it's sprint, because if you look up here, it's by far the highest, and so 20 people like doing sprint. So the most common is also classed as mode, which we discussed at the last part. So the mode is the item that costs the most, and so in a bar chart it will be the highest. And rather than calling it mode, half the time we call it a modal. Remember what I said before in one of the previous lessons? Maths has its own language, and sometimes the difficulty with maths is just trying to understand what that language is. So just maybe you can get a notebook and write these different words in so that you become more familiar with them. So you will get asked things like, what is the modal value? And is it possible to have no modal value? And the answer is yes, because as before, it's possible not to have a mode. Now, this is just to show how good bar charts are, because if I wrote out all the different things that people liked in a list like this, it would be a complete nightmare. And you also couldn't tell which is most popular, because of course the word long distance is much longer than sprint, so it could go on for 3 lines but have less. Hopefully that makes sense to you. So that's why we put it all in a graph so you can see at a glance what it means. So these figures show the number of Year 11 pupils that attend a school athletes club. Now I just want you to have a think about the questions. So pause now, read through the questions, and then come back to me and we'll talk through them. Okay, welcome back. So, over how many weeks were the results collected? Okay, well, pupils, they go to school, and that's when they're not off in this, with 5 days. If we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 times plus 9 is 18. So it went over 18 weeks. So that was, I did count that right, wasn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so 18 weeks it went on. So what is the modal number of pupils attending? So remember, the modal is most, but this is a list of each week that they attend. So in that, the modal number, the modal number would be, where am I here? 16. Now half the time is people make mistakes by saying 15. Whilst 15 repeats itself a lot, the biggest week that more pupils attended was when 16 pupils attended in one lesson. So that would be the modal value. Are there any unusual results? Oh yes, this one is a very unusual result. So why do you think that might be? Why would 1 week no students turn up? Okay, personally I think it's probably half term, when no pupils are at school, and therefore the after school club just isn't on. So when we have an unusual result like this, we call them outliers. That means they lie outside of what we're looking at, and we will talk about outliers later. Now, if the data set were very large, what would be the best way to find the mode? Hopefully, especially from the last few lessons we did, you'd say by putting them in a bar chart, because by putting in the bar chart, we can see at a glance which of the bars is the biggest. So, looking at this, and this is again what different people did, you can be asked to describe or compare the 2 different graphs. So looking at the 2 different graphs, I'd just like you to think of how you would describe this, and then why do you think this might happen? So pause now and come back to me. Okay, welcome back. Okay, so from this, we have to be careful because if you can see here, this is still out of 20, but it looks different just because it goes up in fives. So just make sure that you compare like with like. So sprint was 20 here and sprint was 18 there. Now what I would do is I would talk about the averages. So let's do mode first. So the mode in the first graph, the modal event, was sprint and high jump. No, sorry, that was hurdles. So they were the two modal events, where in this one, it was just sprint. I would then probably look at what event had the smallest numbers in. So I'd say the high jump only had 7 people, but if we go to high jump here, okay, it is 10. So therefore, people attending high jump is a lot bigger. Looking at roughly, you could count up how many people attended both, but even from a glance, you can see that more students took part in these events than in these events. So why do you think that might be the case? Okay, we don't actually know why this might be the case because it doesn't actually give us any more information, but the fact that this was long distance running was so much bigger and also hurdles was much bigger than this one, I'd probably say this may have been, for example, in the spring or summer, where this might have been in the winter, so you weren't doing as much outdoor sports. So here's some more graphs. How many sports do you play? Looking at that. Now just look at the following question, so pause and come back to me. Cool. So when we do this, how many pupils play more than 2 sports? So what you do is, this is the bit that's important. More than 2 sports. So more than 2 sports is 3, 4, 5, 6. So if we, give you all the answers there. So if we add them all up, you'll find that that would be 7 plus 4 plus 2 plus 1. And you'd add up together, which would be, I believe that was 14. Yes, it was. Okay, what is the modal number of sports played? Modal, remember, is most, which is up here as 13. And how many pupils took part in the survey? You just basically add up how many pupils took part by putting that's 10 there. That one would be 13, etc. And just adding them all up, which is 45. So a little bit time consuming and fiddly because you're having to read above across a chart. But when you get down to it, not that difficult. So, looking at this graph, tell me what is the modal time and how many girls are in this interval. So what you'd find the modal time is, when you come up to here, the modal one is 8. And when you're actually looking at how many girls are in the interval, again, you just add it up. So that would be 2 plus 4 plus 5 plus 7 plus 8 plus 3 plus 1 plus 1. And you literally just add up all those numbers. So what happens when they don't do it in a nice bar chart and instead they give it to you in numbers, which in some ways is more difficult to understand? So a newspaper, this is how people have used averages, have said you may be surprised to learn that the average number of sports played by university students is 0. Now, do you think that's a fair description, representation of this data? Pause and have a think. Okay, personally, I don't think it is fair. Now, they are completely right because they have talked about the average in one way. What average have they used? Have a think. Okay, the average they've used is modal because the most number is right here, which is at 0. So that's right. But that's quite misleading because if we actually worked out the mean or even the median, we wouldn't find 0. However, the newspaper hasn't lied because it has said the average number of sport, and mode can be seen as the average. Well, it is an average. And this is how sometimes statistics can be used to lead a person to believe one thing, because when you hear about average, most people think of mean, not mode. Now, just to do it and comparing data, what I'd like you to do is look at the screen, and St Clement's Dance School holds an inter-form athletics competition for Year 10 pupils. Each class must select 5 best boys and 5 best girls for the event. Here are the times in seconds for the 100-meter sprint for the 2 best classes, for boys and girls. So how can we decide which class wins? So using your understanding of averages, look through that data, so pause, have a look through the mean, the mode and the median, and then come back to me. Okay, welcome back. Now, I found that the best way to do data like this I would use the mean. To remember, the mean is the sum of the values divided by the number of the values. So if we just look at class 10B and we add up all the sums of the values and divide by 5, the mean number is 14.72. So that's a good way to decide, on average, what is the average time for that group of 5 kids. So, looking back to this, do the exact same to all of them and find the mean. So, hopefully you got the answers that I got above. Now, looking at that, you want to know which group roughly ran the fastest, and you can see it's 10C boys for the boys part, and for the girls it is 10B girls at 14.72. So what I want you to do now is calculate class 10B and class 10C and see if we're just working with class B or class C, which group ran the fastest. And hopefully what you found was this. And so this changes the result slightly, as you can see that 10B in this part would be the fastest and 10C in this part would be the fastest. So based on those results, who should win? Well, the class that would win should be 10B, because on fastest, when you add them together, both 10B girls and 10B boys come together to give the fastest results. However, if we looked at them separately as a class for girls and boys, you'd find that 10C boys was much faster and 10B girls faster. So it depends on where you decide how you want to group the data, and it can give completely different results. Now, just before we go off data, I just want to talk to you about a couple of other things that are talked about when you see graphs, and this is what you call skewed data. Skewed data is when it's all more one end than the other. So the results are coming down like so, or as you can see on average they're going up like so. So this data, because it goes high to low, is called positively skewed. This data, because it goes from low to high, is called negatively skewed. Now, for interest, if you look at the coronavirus and how different people are getting infected, you can see it's an exponential curve, which it can be called as negatively skewed. And it's just a way people talk about data. So again, if you have your booklet of different language used in maths, just write down skewed and just do a little diagram of what that means. And finally, we mentioned this before, is outliers. This is information that doesn't seem to be right compared to the rest of the data. If we looked at this, the school athletes team takes part in an inter-school competition. And when they look at that, they say, what is the mean throw? So, have a look at the data and find out what the mean throw is. Okay, welcome back. Hopefully you've got a good answer. Now what I want to ask is this a fair representation? Now I would personally say no, it wasn't, because if you look at this one, all the rest of them are roughly between high 8s, so nearly 9s, and 10s. So really her average should have been 9 point something. but this data would have massively dropped it down. And because of that, it would have brought down her whole figures. And what could have happened there? Well, she could have tripped. She could have, I don't know, done something completely different. Anything could describe for that data, but because of one bad throw, it shouldn't affect everything else. So, how do you think what's a fair way for a competition to gauge? Something like this. Have a think. Most of the time what they would say is they would give you, say, 5 chances and they would take your 3 best scores. And that will give you a chance to actually hopefully get the best number you can, or they would use the median as the best option, because that way, if you have numbers here, then the middle number should be a good representation of where you are, because it doesn't matter if you have an outlier. So it does usually depend on the data, depending on which type of average you use. But again, this will be discussed later. So, are you red, amber or green? If you're green, carry on. If you're red or amber, just go back and have a look again.